Welcome back guys, this is question 5.48 and the statement of it is every hour 10,000 cans of soda are filled by a machine among which 300 underfilled cans are produced. Okay, so these are the total number of cans among which 300 underfilled cans are produced. Each hour a sample of 30 cans is randomly selected and the number of ounces of soda per can is checked. Denote by X the number of cans selected that are underfilled. We have to find the probability that at least one underfilled can will be among those sampled. Okay, so first of all, let me write the given data here. In given data, the total number of cans here are 10,000. Okay, and 30 are underfilled. Let me represent them with U, and these are 300. Sorry, 300 are underfilled. So now in order to find here the probability of the underfilled, because n here is very huge, so therefore in order to find the probability of the underfilled, we have to write the total number of underfilled dividing it over 10,000. Okay, so it will be what? It will be 0.03. Okay, now each are a sample of 30 candidates randomly selected, so therefore n is what? N is 30, and we have here X, the number of cans selected that are underfilled. Okay, these are the underfilled cans. So so what do we have to find out here? Let me write here the required data. So we want to find out the probability that X is greater or equal to 1. We have to find it out. Okay, so in order to find it out, we can also write it this P of X greater or equal to 1. This is also equal to 1 minus probability that X is less than 1. Okay, so less than 1 is what? This less than 1 is basically equal to 0. Okay, so we have to find it out. So okay, so this is the required thing we have to find here in this question. Okay, so now solving it, we can very clearly see that it is the binomial probability problem where the probability is given, the number of items selected are given. Okay, and the items which has to be selected are also given, which is here as well. Okay, so we have to find here the probability that X is greater or equal to 1. This is 1 minus probability of X equal to 0. So this can be written as n choose 0. Okay, and then probability raised to power 0 1 minus p raised to power n minus 0. Okay, let me write these values. So it would be 1 minus n choose 0 is n is 30, and choose 0, p is 0.03. okay, and this is 1 minus 0.03, n minus 0 is 30. Okay, let me write it out. It would be 1 minus, this is what? Let me simplify them. This is equal to 1, this is also equal to 1. Okay, and this remaining term will be what? It would be 0.97 raised to the power 30. Okay, now calculating it and then writing the answer of it would be 0.599, and that is what? That is basically the solution of question 5.48, which is related to the binomial approximation. Okay, we have approximated the hypergeometric probability to the binomial approximated probability. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 5.49 and the statement of this question is the probability that a person living in a certain city owns a dog is estimated to be 0.3. Okay, so the probability given here is 0.3. Find the probability that the 10th person, okay, the 10th person randomly interviewed in that city is the 5th one to own a dog. Okay, so what is given here? Let me write here. Okay, this is the given data. In given data, we have to write that the probability that a person owns a dog is 0.3. Okay, and also we have to find the probability that the 10th person randomly interviewed in that city is the 5th one to own a dog. Okay, so 10th person who is interviewed is actually the 5th person who owns a dog. Okay, we have to find the probability of it. Okay, so let me write here this probability as well, and this is it. So now in solving this question, what do we have to do? Let me draw the diagram for it. So diagrammatically we can write it like, suppose we have these 10 slots. Okay, we have these slots 1 2 3 up to this 10th slot, 1 2 3 up to this 10th slot. Okay, so here in order to write that whether a person has a dog or not, yes, Y is for a person owns a dog, and for person doesn't own a dog. Okay, so therefore writing it here, this 10th person will be the 5th one who owns the dog, so it will be Y5. Okay, also all previously here we will have all the 4 Y's. Okay, so those would be, let me write here, Y1, Y2, Y3, Y4, anyone, and 5th one will be here. All others will be the person who doesn't own the dog, so those would be N1, N2, N3, N4, and 5. Okay, so 5% here will be the people who doesn't own the dog, while the 4 ones here will be the person who owns the dog. Okay, so therefore this will be what? This will be the probability here, and here in order to write them here, what would we get for this combination here? We would get here the total number of people who owns the dog would be 0.3, which is the probability that a person owns a dog. 0.3 multiplied by 0.3 multiplied by 0.3 multiplied by 0.3 and multiplied by 0.3. Why is it? Because this is Y1, Y2, Y3, Y4 and Y5, and multiplying them all together, we will get what? We will get the probability that a person, all the persons that who owns the dog, this is the probability for them, and also for them as well we have to multiply their probability as well, and it would be 1 minus 0.3, so 0.7, 0.7, 0.7 multiplied by 0.7 and 0.7 as well. These are all multiplied with them as well, so it is N1, N2, N3, N4 and 5. So here we will get what? It would be, the answer of it would be 0.3 raised to the power 5 and 0.7 raised to the power 5. This is for what? This is for this specific combination. Okay, but keep it in your mind that there is a possibility that here we can have N1, here we will have Y1, and here we will have Y2, and so on. There can be many combinations for these 9 items. Okay, and each 9 item will give us this probability. Okay, you know that there are n there are 9 items, and out of those 9 we can have here 4. Yes, so this is what, this is clearly the combinatorial problem, where this one is true for only a specific combination, while to find the total number of combinations, what do? We have to find the 9 choose these 4. Okay, these 4 are the yes, so we have to multiply them with this probability, just like we have done in the binomial probability. Therefore this one is called the negative binomial probability. Okay, so now writing it here, what will we get? Here we have the total number of items equal to 9 before it, and out of 9 we have the combinations of these 4. Okay, so this one here, and also multiplying them with 0.3 raised to power 5 and 0.7 raised to the power 5 as well. Okay, so finding it here, we will get 9 factorial divided by this 4 factorial, and 9 minus 4 is 5 factorial. Writing it here as well, so 0.3 raised to power 5 and 0.7 raised to the power 5 as well. Okay, now multiplying them and then finding the answer of it, we will get 0.0515, and that is what, that is basically the solution of our question 5.49. Okay, so that's it for today, in which we have discussed the negative binomial probability. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.50, and the statement of this question is: find the probability that a person flipping a coin gets A, the third head on the 7th flip, B, the first head on the 4th flip. Okay, so in this question we will not only solve this question, but we will also try to understand the difference between the negative binomial probability and geometric distribution as well. So this is what the first part is related to the negative binomial distribution. Okay, while this part B of this question is, this is related to the geometric distribution or geometric probability distribution. Okay, so let us solve them. So first of all, let me solve part A of my question. In part A, the third head on the 7th flip means the coin has been flipping and the person has flipped it 7 times, and on the 7th flip he has got third head. Okay, so therefore let me again illustrate it with the help of this diagram. So it has 1, 2, 3, 4, 5, 6 and 7 slots. Okay, and in this slot, this is the 7th slot here, this is the 7th slot here, and here we have got our third head. Okay, so let me call it H3. Okay, so H1 and H2 will be somehow here. So we have H1, H2 here in all these 6. Let me represent them with this. So these are the remaining 6 slots. In these 6 slots, we will have 2 heads and also T1, T2, T3 and T4 tails. Okay, so here what would we get in order to get the 3 heads and 4 tails? The answer we will get here would be 0.5 raised to the power 3 for these 3 heads, because of H1 multiplied by H2 multiplied by H3. Okay, their probabilities. Okay, let me represent them with P of H1, P of H2, P of H3. So multiplying them, we will get here 0.5, and also for the tails, we will have here P of T1, T2, T3 and T4. So we would get here 0.5 raised to the power 4. Okay. More concisely, here we can write it like P of H1 multiplied by P of H2 multiplied by P of H3. Okay. So it will be what? It will be here. It will be here because 0.5, 0.5, 0.5, and also here for this one P of T1, P of T2, P of T3 and P of T4. Okay, these would be here, and taking them now, multiplying them together, and here we will get this one. Okay, so this is for this specific combination here. Now in order to find different combinations for H1, H2, T1, T2, T3 and T4, because this third will remain here, so therefore in order to write it here for all of them, we will have the total number of items here are 1, 2, 3, 4, 5, 6. Okay, so out of 6 we have to take the combinations with which this H1 and H2 makes with them, so it is 6, choose 2. Okay, so let me solve them. So it would be 6 factorial divided by the 4 factorial multiplied by 2 factorial, and it would be 0.5 raised to the power 7. Okay, so ultimately the answer of it would be 0.117. Okay, and that is what? That is basically the solution of part A of my question. Okay, so all of this is related to the negative binomial distribution, because this is the formula for the negative binomial distribution which we have seen now. Now in order to discuss part B of my question, the first hat on the fourth flip. Okay, so therefore let me move down somehow. Okay, so here what we can do, the first hat on the fourth flip means we will have here 4 slots. Okay, and in this 4 slot we will get what? Here we will get the first head, while all the others will be tails. T2, T3 means these are basically the successions until and unless we get this heads, which is basically the success. So the number of trials or number of flips until and unless we will get heads or the success is basically represents the geometric probability distribution, and the probability of it would be what? It would be, this is probability of T1 multiplied by the probability of T2 multiplied by the probability of T3. Okay, so these are basically the failures or the tails, and the success we call to the head. This is here P of H1. So therefore it would be 0.5 multiplied by 0.5 multiplied by 0.5. This would be 0.5 raised to the power 3, and multiplying it with the probability of H1, and let me call it 0.5 as well, and it is what? It is basically 0.5 raised to the power 4, and this is what? This is basically the solution of question 5.50 part B. Okay, so in this question or in this part we have discussed what? We have discussed the geometric probability distribution, which is basically the goal of my question, in which I have to discuss the difference between binomial probability and geometric probability distribution. So that's it for today, in which we have discussed that negative binomial distribution basically we get when the number of successes are available in all the trials, but we have certain number of successes and we want to identify that a certain number of success has been occurred at some trial, while in the geometric probability distribution we will do the trials and unless and until we will get the success or the required outcome. So that's it for today. If you have any question, you can ask me in comment box. See you soon.
Welcome back, guys. This is question 5.51.
And the statement of this question is 3 people toss a fair coin and the odd one pays for coffee. If the coins all turn up the same, they are tossed again. Find the probability that fewer than 4 tosses are needed. Okay, so this is the statement. Now first of all, let me write the given data. Okay, so what are the conditions which are given here? So there are 3 people who are tossing a fair coin. If the coins all turn up the same, they are tossed again. Okay, what does it mean? The 3 people are tossing a coin and the odd one of them, okay, if one is tail, 2 are heads, then this tail will pay for the coffee. Similarly, if one is head and the other 2 are tail, this heads one will pay for the coffee. Okay, so this is what we have. Similarly, there can also be the option that all the 3 outcomes can be the similar one. I mean, it can be tail, 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 or it can be heads, heads, heads. Okay, so in mathematics you know that how to write this or. This or can be written as plus. Okay, and to write the probability that all are same, we have to write the probability of tail multiplied by the probability of tail multiplied by the probability of tail plus probability of heads, the probability of heads multiplied by the probability of heads. Okay, what does it mean? This is basically the probability that we are getting the similar outcomes. Okay, so here putting the values 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2 plus 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2, because these are independent of each other, or it can be 1 by 8 plus 1 by 8. So ultimately it will give me 1 by 4, which is the probability of similar outcomes. Okay, that is what we have. Similarly, the probability of the different outcomes in which one is the different, this can be found out by 1 minus probability of similar. Okay, so it will be 1 minus 1 by 4, which is 3 by 4. Okay, so that is what, that is basically the probability that we will get the different number of items here. Okay, which can be either this or this, in which the odd number of the item will be present here. Okay, so now in order to find the probability that fewer than 4 tosses are needed, one we can write, let me write here the solution. Here the probability that x is less than 4, it can be what? It can be written as either in the first toss we will get these total number of items, which are what? Which are basically the different one. Okay, so this can be the first trial in which we can get this 3 by 4 probability, or it can be the second one, means in the first trial we will get this similar and the second one we will get 3 by 4. So this would be 1 by 4 multiplied by 3 by 4, or okay, so this was the first trial, this is the second trial. In the third trial we can also get what? There is also a possibility that in the first 2 trials we will get the similar ones, which are 1 by 4 multiplied by 1 by 4, and the last one we will get 3 by 4. Okay, this is also a probability. So these situations can also occur here. Now writing them here, it will be 3 by 4 plus 3 by 16 plus 3 by 64. Okay, so now this is what we have. Adding them all together, what we will get, the answer of it would be 63 by 64, and that is what? That is basically the solution of my question 5.5. 5.1. Okay, so that is basically the solution of my question, in which I have basically used what I have used the geometric probability theorem. This is for the condition where we will get the success in the first trial. This is what we will get the success in the second trial, while this is what we will get success in the third trial. Okay, so that's what we have done for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.52, and the statement of this question is: a scientist inoculates mice one at a time with a disease germ until he finds two, okay, so let me underline it, that have contracted the disease. If the probability of contracting the disease is 1 by 6, what is the probability that 8 mice are required? Okay, so now in solving it, let me solve it here. Okay, first of all, let me illustrate it by using this diagram. Okay, so let me have here this slot in which I have 8 slots. Okay, so here this will be done until and unless he will have here the 2 mice. Okay, so here let me write here, this one is the first, second, third, fourth, fifth, unless and until here we have the 8th one, and here we have to find its probability. 8 mice are required, and here if 8 mice are required, the last one here would be what? This will be the second mice. Okay, one will be here somehow, so here this one will be the second one, or another one will be here. So here we will have 2 mice which have contracted the diseases. Okay, so therefore the probability that 2 mice has contracted the disease while the 2 has not, so this is the probability of the contracting the disease is what? This is 1 by 6, and the probability of not contracting the disease, this is 1 minus p of d, that is 5 by 6, because this is 1 by 6. Okay, so here as 2 mice are here which has the disease, while the remaining 6 mice will not have the disease, so therefore the answer of it would be what? It would be 1 by 6 raised to the power 2 and 5 by 6 raised to the power 6. Okay, so this is for the only one combination which we will have here, but here we can see that here we have, this is 6, this is 7. Okay, here we have what? Here we have these 7 slots. In these 7 slots we can have 1 mice which has contracted the disease anywhere here, so therefore out of them which we have 7 slot, we can have only one which can get here. Okay, so writing it here, what I can write here, it would be 7 factorial divided by 6 factorial into 1 factorial multiplied by 1 by 6 raised to power 2 and 5 by 6 raised to power 6. Okay, so here we will have 7 multiplied by 1 by 6 raised to power 2 and 5 by 6 raised to power 6. Okay, calculating it, the answer of it would be 0.0561, and that is what? That is basically the solution of my question 5.52. Okay, so you have seen that what is this? This is basically the negative binomial probability okay, and we have solved it by using this formula which we have got from this one. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.53, and the statement of this question is: an inventory study determines that on average demand for a particular item at a warehouse are made 5 times per day. what is the probability that on a given day this item is requested, part A, more than 5 times and part B not at all. Okay, so this is basically the problem which is related to what? Which is related to the Poisson distribution. Okay, and the formula for calculating the number of times an item is requested which are greater or lower than the average number of times will be the probability that x is equal to k, where k are the number of times an item is requested or done. It would be what? It would be the lambda k, okay, exponential of minus lambda divided by the k factorial, where k is what? K are basically the number of items and lambda is the average amount. Okay, so this is what we are going to do today. Okay, so in part A of my question, we can see that very easily we have to find the probability that the items are what? Items are more than 5 times. So we have to find this one, and it can be calculated by 1 minus the probability that the items are less than or equal to 5. Okay, we have to keep in our mind that the average number of times an item has been ordered is what? That is also 5, which is given here. Okay, in order to find it out, we know that the probability that x is less than or equal to 5, this can be calculated by summing the Poisson distribution from k equal to 0 up to 5. Okay, and it would be what? It would be the lambda k exponential of minus lambda divided by the k factorial. Putting values here, what I will get here, k equal to 0 up to 5, lambda is 5 here, so 5 raised to power k and exponential of minus 5 whole divided by the k factorial, or taking it out, this is a constant, exponential of minus 5, and the other items here would be from k equal to 0 up to 5, 5k divided by the k factorial. Okay, let me write them down. It would be what? It would be the exponential of minus 5, and it would be 5 divided by 0 factorial plus 1 divided by 1 factorial, because k is ranging from 0 to 5. Also 5 square divided by 2 factorial plus 5 cube divided by 3 factorial plus 5 raised to power 4 divided by 4 factorial plus 5 raised to power 5 divided by 5 factorial. Okay, so finding it out, and then let me move down somehow. What we will get after calculating it out, 0.616. Okay, so this is what? This is for the probability that x is less than or equal to 1. Okay, so now we have to find out the probability that x is greater than 5. So therefore we have to subtract it from 1, because this is the thing which we want to find out. So let me point it out here. Okay, this is what we wanted to find out. So therefore the probability that x is greater than 5 would be what? It would be the 1 minus the value of probability x is less than or equal to 5. This is 0.616. Let me put it here. Okay, so now subtracting it from 1, what I will get, the answer of it would be 0.384. Okay, so that is what? That is basically the solution for part A of my question. In solving part B of my question, what do you have to do? You have to put the value of k equal to 0, because this is for not at all, and here it will be for k equal to 0. Putting k value equal to 0 here, the answer of it you will get will be the answer of part B of my question. Okay, so that's it for today, in which we have seen the introduction to the Poisson distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.54, and the statement of this question is: according to a study published by a group of University of Massachusetts sociologists, about two-thirds, okay, let me underline it, two-thirds of the 20 million persons in this country who take Valium are women. Assuming this figure to be a valid estimate, find the probability that on a given day the fifth prescription written by a doctor for Valium is A, the first prescribing Valium for a woman, and B, the third prescribing Valium for a woman. Okay, so in this question, what do we have to do? We have to use our developed concepts regarding the probability distribution to see that which probability distribution will be valid here. Okay, so in part A of this question, we can very clearly see that the fifth one will be the first one. Okay, so this can be translated like that the events have been done unless and until we have get the success. Okay, so this is part A. Let me write here. Okay, so solving part A of my question, we can very clearly see that this is what. Let me represent it by using this diagram, okay, in which we have 5 slots. Okay, and here this is the fifth one, and this fifth one is what? This is the first prescribing Valium for a woman. Okay, so means this is the first for this one, while all the others were not for the woman. So therefore the probability of it was what? The probability of it was 2/3. Okay, means this was 2/3, and all others were 1/3, 1/3, 1/3, and 1/3. Okay, so in finding the total probability of these independent events, we have to multiply them together, and ultimately we will get 1/3 raised to the power 4, 2/3 multiplying with it. Okay, so this is what? This is basically the representation related to the geometric probability. Okay, so the part first of A is related to the geometric probability. In part B, the third prescribing Valium for a woman. Okay, so it means that this is not the first one, while the third one is fixed, which is the fifth one. So that's why here we have to use what? Here we have to use the negative binomial distribution. Okay, so you have to keep in your mind that in geometric probability distribution, the last one is the first one, which is the success, while in the negative binomial distribution, there is not a fixed last one, which is the first one, while it can be any fixed number of the trial which has been done over this last trial. Okay, so let me again use the same representation for it. Okay, so there are 5 slots. Okay, this is the fifth one. This is 4, 3, 2, 1. Okay, this fifth one is what? This is basically the third prescribing Valium. Okay, means this is what? This is 2/3 probability. Okay, while these 4, out of them there can be 2 prescribing women, and the 2 non women here would be here as well. Okay, so therefore what we can do here, these 2 can be anywhere here. So this is the combinatorial problem. So therefore we have to take all these 4, and out of these 4 we have to make the arrangements for the 2 prescribing Valium. Okay, the probability for the prescribing Valium are 2/3 raised to power 2. Okay, because 2 item will appear here, and the non-prescribing non-women item here will be 1/3, and those would also be 1/3, and here this 2/3, which is for this fifth item, will also be here. Okay, so writing it again here, it would be 4 choose 2. Okay, and this 2/3 multiplied by this 2/3, it would be 2/3 raised to the power 3 and 1/3. So this is what? This is the solution for part B of my question, which is related to the negative binomial distribution. Okay, so that's it for today, in which we have seen the relationship between the geometric probability and negative binomial distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.55 and the statement of this question is the probability that a student pilot passes the written test for a pilot's license is 0.7. Find the probability that a given student will pass the test on the first try and before the fourth try. Okay, so let me first write the given data here, that the probability that he will pass a test is 0.7 and he doesn't pass the test, let me call it Q, and that Q is 1 minus 0.7, that is 0.3. okay, so this is the given data. In part A of this question, let me solve it. So solving it, in part A of my question, I am asked that on the third try he will pass the test. So this is what, this is basically the geometric probability distribution in which a person will try and will solve or will pass the test on the third try. Okay, what does it mean? That, let me draw here this hypothetical diagram. Okay, there is first try, second try, and then third try. Here he will not pass it, so therefore here it will be Q, and here it will be P. Okay, so therefore now let me write their probabilities. So the probability which is Q here is 0.3, here it is 0.3, and here it is 0.7. so therefore the answer of part A is what? That is 0.3 multiplied by 0.3 multiplied by 0.7. so that is 0.3 whole square multiplied by 0.7, which is what? Which is 0.0630, and that is what? That is basically the solution of part A of my question. Okay, in part B we are asked that a person will pass the test before the fourth try. Okay, what does it mean? That he has to pass the test before the fourth try, means before fourth try. What does it mean? It means that he has to pass it on or before the third try. Okay, so he has two tries are less than or equal to 3. What does it mean? That he has to try and pass them less than or equal to 3. What does it mean? That the try is first, or the try is second, or try is third. He will either pass it on the first try, on the second try, or on the third try. Okay, so let me write their probabilities, and each term here is basically what? Each term here is basically the geometric probability where the terms here will be given. So therefore let me write their probabilities. So on the first try he will pass it, the probability of passing over the first try, I have to write it here, or the probability of passing it over the second try, and the probability of passing it over the third try. I have to write their probabilities. So in order to write the probability of it, the first try and he has passed it, the probability of it is 0.7. okay, in the second try means he has failed it on the first try, so therefore it will be 0.3, which is the first try he has failed it, and then on the second try he has passed it, so therefore this is 0.7. in the third try means he has failed it on the first two tries and passed it over the third try, which is what? Which is the given one here as it is in part A. So therefore it would be 0.3 whole square multiplied by 0.7. okay, so these are what? These are the individual geometric probabilities for each of the terms which are here. Okay, so now calculating it and then adding them all, the answer of it would be 0.9730, and that is what? That is basically the solution for part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.55, which is related to the geometric probability distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.56 and 5.57, which are closely relevant with each other. And today we are going to discuss the probability distribution, which we are going to follow and solve the questions like this one. So in question 5.56, the statement is on average 3 traffic accidents, okay, 3 traffic accidents per month occur at a certain intersection. What is the probability that in any given month at this intersection, A, exactly 5 accidents will occur, B, fewer than 3 accidents will occur, and C, at least 2 accidents will occur. Similarly, in 5.57, we are also given some average number of errors in the textbook, and all of these questions where the average number of traffic accidents, average number of errors, average number of items are given, and we have to find the exact number of accidents or exact number of errors, or some maximum or minimum limit of accidents or errors are given. So there, what would you do? You will have to use the probability distribution, which is very famous, and that is basically the Poisson probability distribution. And the formula we are going to use for it is probability that x equal to k, that is equal to the exponential of minus lambda and lambda raised to power k divided by the k factorial, where lambda is what? Lambda is the only factor here, which is the average value. Okay, so in each question here, average values are given. This is 3 and here we have 2. Okay, so in order to find them out, let me first solve question 5.56, and in solving it, let me use this black color. Now let me solve question 5.56, and in solving it, this is the solution. And let me first write the given data, where the given lambda or the average value is 3 accidents per month. Okay, so this is lambda. In part A of it, what do we have to find out? Exactly 5 accidents will occur. So if suppose x is the number of the accidents, we need to find out the probability that x is 5. In B, fewer than 3 accidents will occur. Probability that x or the number of accidents are less than 3, which is here. And in C, at least 2 accidents will occur, means probability of x is greater or equal to 2. Okay, so here we have to find it out, and previously I have told you guys that the formula for the Poisson distribution here would be what? That would be probability of x equal to k, that is equal to the exponential of minus lambda k divided by the k factorial, which is written here. So now as this lambda is given, so it is clearly the Poisson probability distribution problem. So therefore, let me write here this px equal to 5. So for it, k is equal to 5, so therefore it would be the exponential of minus 3, and lambda, which is 3 as given here, this is 3, the value of k is 5 here. Okay, so this is 5 divided by the 5 factorial. Okay, so what would we get? Exponential of minus 3, this 3 raised to power 5 is 243. Okay, multiplying it with it, and 5 factorial is 120. Okay, so finding the value of exponential of minus 3, what would we get? 0.0498 multiplied by 243 divided by 120. Okay, and then finding the answer of it, the solution would be 0.1008, and that is what? That is basically the solution for part A of my question. Okay, in part B, which is basically this one, let me solve it here. Okay, this is the probability that x is less than 3. This is what? This is basically the probability that x is less than or equal to 2, or we can very easily write it all the values of x is less than or equal to 2, those would be the probability that x is equal to 0, the probability that x is equal to 1, and the probability that x is equal to 2. Okay, so these are all what? These are all the Poisson probability formulas, where in each of them I have to use the formula which we have here. Okay, for all of them the values of k are 0, 1, 2. So let me write their values. So in this formula, putting these values, it would be exponential of -3, because the value of the lambda will remain the same. Okay, multiplied by the 3 raised to power 0 divided by the 0 factorial plus exponential of -3 into 3 raised to power 1 divided by 1 factorial plus exponential of -3 multiplied by 3 raised to power 2 divided by 2 factorial. Okay, so finding it out, because the value of exponential -3 is already known, and then finding the other values, the answer of it would be what? The answer of it would be 0.423. Okay, so this is the solution for part B of my question. In order to proceed to part C of my question, let me move down somehow. Okay, so part C of this question is probability of x is greater or equal to 2. We can very easily find it out by 1 minus probability of x is less than 2. Okay, so it would be what? It would be 1 minus the probability of x equal to 0 plus the probability that x is equal to 1. These are the values which are less than 2. So again, these are for the Poisson distribution. Let me write them here. 1 minus probability of x equal to 0, it would be x exponential of -3 3 raised to power 0 divided by the 0 factorial plus exponential of -3 3 raised to power 1 divided by 1 factorial for the values of k equal to 0 and 1. Okay, and then adding them, subtracting it from 1, what would I get? It would be 1 minus exponential of -3 multiplied by 4. So ultimately the answer of it would be 0.8009. Okay, so that is what? That is basically the solution for part C of my question. Okay, so this is basically the solution for question 5.56. Now let us proceed to question 5.57. On average, a textbook author makes 2 word processing errors per page on the first draft of her textbook. What is the probability that on the next page she will make 4 or more errors and B, no errors? Okay, so in this question again the average value is given, which is 2. Okay, and the formula is already given. Let me move down somehow for this one as well, and let me use this blue color for it. So this is question 5.57, and in part A of my question I have to find probability that 4 or more errors are here. So if I represent the number of errors with x, so x are greater or equal to 4, so it would be 1 minus probability that x is less than 4. Okay, let me write them here. So it would be all the values of x would be probability of x is 0 plus the probability that x is equal to 1, the probability that x is equal to 2, and the probability that x is equal to 3. Okay, the value of lambda is already given, which is what? Which is 2. So this is here as well. Okay, let me use the same formula which I have used for it, which is here, which is exponential of minus lambda raised to power k divided by k factorial. Okay, so let me write them here. It would be 1 minus exponential of -2 raised to power 0 divided by 0 factorial plus exponential of -2 raised to power 1 divided by 1 factorial plus exponential of -2 raised to power 2 divided by the 2 factorial plus exponential of -2 2 raised to power 3 divided by the 3 factorial. Okay, so then solving it and finding the answer of it, the answer of it would be 0.1441. Okay, and that is what, that is basically the solution for part A of my question. And moving to part B of my question, I have to find the probability that we will get no errors. So this is what I want to find out, the probability that the number of errors are 0. Okay, this is x equal to 0, or this is the same one as it is here. So therefore writing it, exponential of -2 2 raised to power 0 divided by 0 factorial, which is same as exponential of -2. So the answer of it would be 0.135, and that is what, that is basically the solution for part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.56 and 5.57 by using the Poisson distribution, okay, which is the formula which we have written here. So I hope this is now understandable, and if you guys have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.58, and the statement of this question is: a certain area of the eastern United States is on average hit by 6 hurricanes a year. Find the probability that in a given year that area will be hit by A, fewer than 4 hurricanes, B, anywhere from 6 to 8 hurricanes. Okay, so this is one of the problem which is related to the Poisson probability distribution. What we can do here is that we can solve it by two methods. One is by using the formulas, which I am going to write here. Okay, so the formula here is the probability that x equal to k equal to exponential of minus lambda k divided by the k factorial, where lambda is the average value given here already, and here lambda is 6. Okay, so in order to find the fewer than 4 hurricanes here, what we can do, we have to find the probability that x is less than 4, which is the probability that x is less than or equal to 3. What we can do here is that we have to find the probability of x equal to 0 plus x equal to 1 up to also probability that x equal to 2 and plus probability of x equal to 3. These are all the values of k. Writing them here, lambda will remain the same. You have to add them, and then you will find the probability of it. Okay, this is basically one method. The other method is the use of the Poisson distribution table. Okay, so here we have a table, and in that table what we can do here is that we have this value which is k, and also the value of lambda which is given. These are the two factors here we have, and these are the two parameters which are going to be the searchable parameters in the table. Okay, let me go to the table now. This is the probability that x is less than or equal to 3. Let me go to the table. So this is the table, you can see it here. Okay, so let me increase it. Okay, you can see here that this is a table, and these are all the values for the lambda 0.1 up to 1.8, and all the values of it are basically what? These are the values of the lambda, while these are the values of x or k. Okay, these are the values. So we have to do it for what? Our value of lambda is here 6. Okay, so we have to search for 6, and in the column of the x we have to search for 3. Okay, so there we will find that this is the formula, and here you will have to do it. Okay, this is basically lambda. Okay, not -1. Okay, so now let me search for 6. Okay, so this is 6, this is for lambda. Okay, what we have here, and for the value of x we have here 3. Okay, so here it will be the value, because we have to find out the probability that x is less than or equal to 3, and for that we had here 6, and so therefore the answer of it is 0.15 1 2. Okay, and that is what, that is basically the solution of part A of my question. 0.1512. Okay, so that is what, that is basically the solution of part A of my question. In part B, we have to find the probability that it is anywhere between 6 to 8, means it is greater or equal to 6 and less than or equal to 8. Okay, so therefore let me move to the same page in the table. Okay, so this is the similar one, and here we have to find out what, we have to find that x is greater or equal to 6 and less than or equal to 8. Okay, so here what would happen, we have to subtract the value of x is less than or equal to 8. From it we have to subtract what, we have to subtract the value of x which is less than or equal to 5, because 6 should remain in between them. Okay, so it should be here. Why? Because if this is the table and here we have here the 8th one and we keep it here the 5th one, so all the values will remain here would be from 6 to 8, and therefore we have to keep them here as well. Okay, so now let me find out the value of lambda will remain the same, which is 6, and the value of x is less than or equal to 8. Here it is this one, this would be 0.8472, 0.8472 minus probability of x is less than or equal to 5. This is 0.4457. Okay, so when you will subtract it from it, it will be around 0.40, which is what, which is basically the solution or answer of part B of my question. Okay, so this is what, let me move to the main page. So the answer of part B is 0.40. Okay, so that's it for today, in which we have solved question 5.58 and seen that how to use the Poisson distribution table in finding the probabilities whatever we have. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.59, and the statement of this question is, suppose the probability that any given person will believe a tale about the transgressions of a famous actress is 0.8. What is the probability that, part A of it is, the 6th person to hear this tale is the 4th one to believe it, and B, the 3rd person to hear this tale is the 1st one to believe it. Okay, so in solving these type of questions, what do we have to do? First of all, we have to recognize that which probability distribution we should have to use. So in part A, it can be very clearly seen that this is the problem of the negative binomial distribution. Why? Because here we have different successes or different events has taken place, and one of that event has been fixed over some position, such like the 6th person is the 4th one. Okay, so this is what, this is the negative binomial distribution. This last one here, which is part B, is the 3rd person to hear this tale is the 1st one to believe, means the 3rd person will be the 1st one who will believe. So that's why the event or trials has to be done unless and until we have get the 1st person. So that is what, this is basically the geometric probability distribution. Okay, so you have to keep it in your mind. Given data, the given data here we have is the probability that a person will believe is 0.8. so he doesn't believe will be Q, and that is 1 minus 0.8, which is 0.2. Okay, so this is what we have. Now let me solve part A of my question. What do we have to do? Let us again have this hypothetical diagram, okay, in which we have 6 slots. Okay, 1, and these are basically 6, 1 2 3 4 5 6. Okay, and here we have, this is the 1st, 2nd, 3rd, 4th, 5th, 6th. Okay, here this is the 4th person here who will get what, who will believe it. So this is the fourth person who has the probability of 0.8. okay, so this probability is fixed and these persons are fixed. Okay, all other three, this is the fourth one, so the three remaining will be here, and also two remaining which doesn't believe are also here. Okay, so there can be any combination of them. Okay, so therefore it is 0.8. okay, so all other, any two of them will be here, three of them will be here, so these three of them will be 0.8 multiplied by 0.8 multiplied by 0.8, which will be 0.8 cube, and these other twos will be the person who wouldn't believe, so it would be 0.2 whole square. Okay, so these are here, but this is for only one combination. If you want to find out the other combinations of these five, we have to choose from these five, what we have to choose three which are what, which believe all these things. Okay, so let me make it more concise. So it will be 5 factorial divided by the 3 factorial multiplied by 5 minus is 2 factorial. Okay, multiplying it with 0.2 whole square, and also this one which is 0.8 raised to power 4. So this is what, this is the solution of part A of my question. Okay, so you have understood that this is the negative binomial distribution. In part B of my question, let me solve it here. The third person to hear this tale is the first one to believe. Let me again here this hypothetical diagram. This is 1, 2 and 3. This is first, second, third. Okay, the first two person would not believe, so therefore the probability of it would be 0.2 multiplied by 0.2, and the last person would believe, so it would be 0.8, so it would be 0.2 whole square multiplied by 0.8, and that is what, that is basically the solution of part B of my question. Okay, so that's it for today, in which we have seen that how to recognize that certain probability question is of negative binomial distribution problem or geometric probability distribution problem. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.60, and today we are going to discuss the difference between the binomial distribution and Poisson distribution, where to use the Poisson distribution and what are the cases where you can use the binomial distribution. Okay, so let us first go through the statement of this question. The average number of field mice per acre in a 5-acre wheat field is estimated to be 12. Okay, so the average number of mice are given. Find the probability that fewer than 7 field mice are found on a given acre. Okay, so in the first here, let me have here the given data. You can see that here we have to find the fewer than 7 field mice in a given acre, where the average number of mice in an acre are given. Okay, so this is what, this is the lambda or the average number of mice. So wherever you will get this average number of amount and you want to find out some other amount or some other number of amounts, so that is the case where you have to use the Poisson distribution. Okay, so here we have this, and what do we have to find out? In A, we have to find out probability that fewer than 7 field mice are found, or the probability that x is less than 7, which is the similar one as the probability that x is less than or equal to 6. Okay, so here what we can use the formula here as well, which would be exponential of minus lambda of k divided by the k factorial, and then it will be for all the values of 6 or less than 6, so therefore it will be from k equal to 0 up to 6. Okay, this is one method. So it will be what you have to do it all for all the values from 0 to 6 and taking them and then adding them out. Instead of it, we can use a very simple method, and that is basically the use of the Poisson probability table. Let us have it here. So this is the Poisson probability table, and here we can very clearly see that these are all the values for what? These are all the values for the lambda, and these are the values for k or x. Okay, so what is the value of lambda? The value of lambda here is 12. So let me go to 12 here. Okay, So here we have this 12. Okay, this is the column for the 12, and what do we have to do? We have to find the value of x or k which is less than or equal to 6. So therefore it will be here, and let me go through it, and it is the value which we can take, because this is the similar value. You can see here that this is the value we have to find out, and this is the similar formula we have here in this question. Okay, so you can see that this is the similar one, and using this one here and then finding the value, we have found out that this is what this is 0.0458. let me write it here, 0.0458, and this is what, this is basically the solution of part A of my question. Okay, this is the solution of part A of my question. Let me move to the part B of my question. In part B, we are asked to find that on a 2 of the next 3 acres inspected, what is the probability that fewer than 7 field mice are found. Okay, so now initially we had this 1 acre. We have found out the probability that x is less than or equal to 6. Now we have what? We have 3 acres. Okay, there are 3 acres. These are 1, 2, and 3. Okay, and we have to find out that in any 2 of the next these 3 acres, okay, what is the probability that 7 field mouse are found. Okay, we have found out the probability of the 1 acre, and what is the probability that 2 of them will have this probability. This is clearly what? This is clearly the problem of the binomial probability. Okay, what do we have to find out? We have to find the probability that x is equal to 2 for from the 3 ones. Okay, so therefore we have to choose 2 from 3. Okay, and then in each the probability of getting this condition is given, and that is here. So this is 0.0458. okay, square, because 2 should have this probability, and the remaining one here is 1 minus 0.0458. okay, so this is what? This is 3 minus 2, which is 1. Okay, this is why, because we know that the probability that x is equal to k in binomial probability, that is n choose k, p of k and 1 minus p n minus k. This is for the binomial probability. Okay, so now we have it. Now finding the values of it, and then the solution of it, the answer of it would be 0.0060, and that is what? That is basically the solution of part B of my question. Okay, so in this question you have seen that where to use what. In part A we have this average number of mice. From it we have found out the probability that fewer than 7 field mouse are found in a given acre, and the second one, once we have found out this probability, then we had to find out that in the next 3 of them, what is the probability that 2 of them will have fulfilled this condition. Okay, so we have the condition for only 1 acre. If 2 are found, for definite for them we have to use this, what we have to use this binomial probability. Okay, so that's it for today. If you have any question in mind, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.61, and the statement of this question is: suppose that on average 1 person in 1000 makes a numerical error in preparing his or her income tax return. If 10,000 returns are selected at random and examined, find the probability that 6, 7 or 8 of them contain an error. Okay, so now in this question, what we have found and what we have is basically the person in the total number of persons who are making an error. Okay, so from it we can very easily calculate the probability of an error. So what is given from it? we can very easily find out the probability of error, and it would be the number of person who makes the error divided by the total number of persons, which is 1000. So we will get it 0.01. okay. Similarly here, from the samples of 10,000 people, we have to find out that what is the probability that 6, 7 or 8 of them contain an error, which are the documents. Okay, so here we have the samples which are 10,000 which are given here. Okay, so clearly it is what here we have this, and from it I have to find the documents which contain 6, 7 or 8 error. So clearly it is basically the problem of the binomial probability. Okay, so in binomial probability we have the probability, we have the total number of samples, and we have the number of samples we wanted to find out. So what we can do here, by using the binomial probability, we can very easily do what? In solving it, if I want to find out the probability that x is 6, 7 or 8, I have to find out the probability that x is equal to 6 or x is equal to 7 or x is equal to 8. Okay, so these are what we have to do. But now here, in order to use the formula, what is the formula? We know the formula, which is x equal to k. That would be the n choose k. From it the probability is p, this is k, and 1 minus p and minus k. Okay, so we have to do it for this, and for this. So let us first do it for k is equal to 6. So for x equal to 6, writing all the values, n is 10,000. okay, so 10,000 here, k is 6. okay, the probability is 0.01 raised to power 6, and this would be 1 minus 0.01 raised to power 10,000 minus 6. okay, so from here you can very easily see that this one will give you what? It will be very higher. okay, this k here is giving you the values, but here you can very easily see that this n is very higher while this p is very small. So in that case, in what we will do, we will find it for this one, for this one, for this one, and with it we have to do a very heavy calculations. okay, so instead of using the binomial distribution, here this binomial distribution converges to the Poisson distribution. okay, so this is the case, Poisson distribution or Poisson approximation. okay, so that is basically the case where any binomial distribution basically converges to the Poisson distribution. okay, so here in Poisson distribution we have to find it what? This one and this one as well by using the formula, and the formula here is, for it we will have the formula x is equal to k. For this k we have to find it by exponential of minus lambda raised to the power k divided by the k factorial for all the values of k, 6, 7 and 8 which are given here. okay, but what is the value of lambda? In order to find the lambda here, lambda is basically the average value. In binomial distribution, in Poisson distribution, the value of lambda is basically np. okay, here we are given n, here we have here p. So let me write their values. N is 10,000, p is 0.01. so from it we can very easily see that lambda is 10. okay, so putting the values of lambda here and then solving it, let me solve it here. okay, so for x equal to k, or for x equal to 6, it will be exponential of minus 10 of 6 divided by 6 factorial for k is equal to 6. Similarly, plus exponential of minus 10 which is for lambda, and then lambda raised to power k which is 7 for here, divided by the 7 factorial plus exponential of minus 10 raised to power 8 for this one, divided by the 8 factorial. Okay, from it we will get the answer by following the approximation and following the formulas we have here. Okay, so this is the second method. The first method was the binomial distribution, which has been approximated into binomial distribution. The third method here is to find it is basically this one, that x is greater or equal to 6 and less than or equal to 8. This basically contains all the values which are 6, 7 and 8. In order to do so, what we can do, we can find it out by x is greater or equal to 8. From it we can subtract all the values which are less than 6. So it would be x is greater or equal to 5. So from it we can find their values and then put them here. Okay, so how to find their values? We can find them very easily by using the Poisson distribution table, which is given here. We have, okay, so this is the Poisson distribution table. Let me move to lambda equal to 10. Okay, and this is what lambda equal to 10. In that we have to find the values at 8 and 5 because x is less than or equal to 5 and less than or equal to 10. So let me find their values. Okay, so at 8 we have the value 0.3328 and at 5 we have value 0.0671. Okay, so let me put their values. 0.3328, 0.3328, and here this value will be what? 0.0671, 0.0671. Okay, so finding the value of it, the answer of it would 0.2657, and that is what? That is basically the solution of our question which we wanted to find out. Okay, so this is what the answer of it. If you wanted to find it out by using this formula, you would have got the same answer. Okay, this will give you the same answer, this will give you the same answer, but this method is a lot easier than the other two methods. Okay, so that's it for today, in which we have seen the solution of question 5.61. If you have any question, you can ask me in the comment box. See you. Welcome back, guys. This is question 5.62, and the statement of this question is: the probability that a student at a local high school fails the screening test for scoliosis curvature of the spine is known to be 0.04. Of the next 1875 students at the school who are screened for scoliosis, find the probability that A, fewer than 5 fail the test, and B is 8, 9 or 10 fail the test. Okay, so here what is given? Let me first write the given data. The probability is given here, which is 0.004, which is here. Okay, similarly the sample size is also given, which is n, and this is 1875. Okay, so on the basis of this, what do we have to find out? Here we want to find out if fewer than 5 fail the test, means the probability that x is less than 5, which is similar as the probability that x is less than or equal to 4. Okay, and also B, the probability that 8, 9 or 10 fail the test, means the probability that x is greater or equal to 8 and less than or equal to 10. Okay, so these are the two probabilities we want to find out. Okay, so now in order to find them out, we have to use what? We can use the binomial distribution as well as the Poisson distribution. But as discussed in the previous section, in these cases where the probability is very low and the sample size is very high, the binomial distribution approximates into the Poisson distribution, and therefore we have to find the average value of it, which is NP, lambda equal to NP. Let me write here the value of N and P. So the value of N is 1875 multiplied by the P, which is 0.004. Multiplying them together, we will get what? The value of lambda would be 7.5. Okay, so now these are the values we want to find out. This is the value we can find by using the manual method. Okay, the formula for the Poisson distribution is x is equal to k. This is exponential of minus lambda k divided by the k factorial for them all. We have to use it for 0, 1, 2, 3, 4 and then add them together. Okay, apart from it, what we can use the Poisson CDF table as well. Okay, so let me move to the Poisson CDF table where the value of lambda is 7.5 or the average value 7.5, and we want to find it for the value of x or k which is less than or equal to 4. So let me find it out. So this is the table. Okay, in order to find it out, let me have the value of lambda, which is what? Which is basically here. Let me go to 7.5. Okay, the value of lambda is 7.5. Okay, this is 7.5 and we want to find out the value of x which is less than or equal to 4, which is here. So this value is 0.1321. Okay, and that is what? 0.1321. Okay, so that is basically the solution of part A of my question, where I have written the answer of it by using the tabular method. Similarly, in part B of my question, what do I have to find out? I have to find out the probability that x is greater or equal to 8 and less than or equal to 10. What we can do here again is that we can use this formula for x equal to 8, 9 and 10 and then add them together. Okay, this is one method. The other method is by using the tabular method, and in that method, what do I have to do? I have to use the x is less than or equal to 10, and from it I have to subtract the values for x which are less than or equal to 8. Okay, so I have to use this formula here. Now this and this, both of them can be found out by using the Poisson CDF table as well, which we have seen previously. The value of lambda will remain the same while the value of x will be 10 and 8. Okay, so let me move to the table. So this is 7.5 and we want to find out the value for 10. Okay, so the value for 10 is 0.8622. So it is 0.8622, which is for 10, and for 8 it is 0.6620, 0.6620. Okay, so this is the value for x is probability of x is less than or equal to 10, and this is for probability of x is less than or equal to 8. So subtracting this one from it, what we will get 0.3376. Okay, so this is what we have here. This is 0.3376 and that is what we intend to find out here. Okay, so this we found out the value for this, and the answer we got from them is 0.3376. Okay, so that is basically the solution for question 5.62 part B. Okay, so that's it for today, in which we have seen the solution of the question which is related to the Poisson distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.63 and 5.64, which are related to the mean and variance of the random variable, which we have discussed previously, and that was related to exercise 5.58 and 5.61. Okay, both of these were related to the Poisson probability distribution. Okay, so before solving these questions, you have to keep in your mind that in Poisson probability distribution, mean is always equal to lambda, okay, which is the average value, and if we know the population value and we know the probability value, we can multiply them together and we get the value of the lambda. Similarly, the value of the variance is also equal to lambda, which is basically the average value here. Okay, so in both of these cases and in Poisson probability distribution, mean and variance both are equal to the average value. Okay, so let us proceed to question 5.63, and the statement of this is find the mean and variance of the random variable x in exercise 5.58 representing the number of hurricanes per year to hit a certain area of the eastern United States. Okay, so in that question, if you have seen the value of, let me solve it, the value of lambda was what? The value of lambda was 6, which are basically the 6 number of hurricanes per year to hit a certain area of the United States. Okay, so therefore here in this question, mean is also equal to 6 and the value of variance is also equal to 6. Okay, this is what this is about question 5.63. In 5.64, we have to find the mean and variance of the random variable x in exercise 5.61 representing the number of persons among 10,000 who makes an error in preparing their income tax returns. Okay, so this was 5.64, and here what we are given here, we are given here the number of samples which are the 10,000. Okay, so in that question what you have seen is, if you can look at to the problem which we have previously solved, we have seen that 1 out of 1000 persons were there, so therefore the probability it had was 0.01. okay, so from it we can very clearly find out the value of lambda, which is np. okay, let me multiply them. So 10,000 multiplied by 0.01, this is equal to 10, which is also found out in that question as well. Okay, so from it the value of lambda is known, so therefore the value of mean is also 10 and the value of variance is also 10. okay, so this is the case in terms of question 5.64. okay, so that's it for today, in which we have seen the mean and variance of the Poisson probability distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.65 and 5.66, and the statement of the 5.65 is an automobile manufacturer is concerned about a fault in the braking mechanism of a particular model. The fault can, on rare occasions, can cause a catastrophe at high speed. The distribution of the number of cars per year that will experience the catastrophe is a Poisson random variable with lambda equal to 5. Okay, so on the basis of it, what is the probability that at most 3 cars per year will experience a catastrophe, and B, what is the probability that more than 1 car per year will experience a catastrophe. Okay, so on the basis of this data provided, let us solve this question. Lambda here we have is 5. okay, and in part B of it, what do we want to find out? What is the probability that at most 3 cars per year will experience a catastrophe? Means I want to find out the probability that x is less than or equal to 3, means at most 3 cars, means all the other values will be less than this one. We want to find out this. And in part B of it, what is the probability that more than 1 car per year will experience a catastrophe, means the probability that x is greater than 1. Both of these probabilities we want to find out. Okay, so first let me solve probability that x is less than or equal to 3. In solving this question, okay, this one, we know that here the formula in the table we have is what? That is the probability that x is less than or equal to small x. Okay, we have something like this one, and we have some value of lambda. On the basis of that lambda value, on the basis of that x value, we can very easily find out the probability of that item. Okay, so here we know the value of small x, we know the value of lambda, which is 5. So let us move to the probability table. Okay, so here this is the probability table, and here let us move to the lambda equal to what? Lambda equal to 5. So this is the lambda equal to 5, and also the value of x, which is what? Which is 3. So this is the value for it, and this is here. Okay, so we know that the value of it is 0.2650, so it would be 0.2650. 0.2650, and that is basically the solution of part A of my question. In part B, as this is not in the form of 8, so therefore it can also be written as what? It can be written as 1 minus probability that x is less than or equal to 1, okay, because here all the values are greater than 1. Here I can write it like this one. So now if I know the value of it, now I know that this is in the form of 8. Now you know the value of x, I know the value of lambda, which is a similar one. So by using the probability table I can find out this value, okay. So let us move to the probability table where the value of lambda is still 5 while the value of x is 1. So here it is, so that is 0.0404. So 0.0404, okay. Once I will subtract it from 1, it would be 0.9596, and that is what? That is basically the solution of part B of my question. This is the part A of my question, and all of this is basically the solution of question 5.65. okay, so that is what? That is basically the solution of question 5.61. This is question 5.66, and the statement is changes in airport procedures require considerable planning. Arrival rates of aircrafts are important factors that must be taken into account. Suppose small aircraft arrives at a certain airport according to a Poisson process at the rate of 6 per hour. Okay, so lambda is given. Thus the Poisson parameter for the arrivals over a period of r is mu is equal to 60. Okay, means here the value of, if this is a solution here, okay, so here lambda is what? Lambda is 6. So on the basis of it, part of it is what is the probability that exactly 4 small aircrafts arrive during a 1 hour period. Okay, so part A of it is what is the probability that x is equal to 4. Okay, because exactly 4 arrive during 1 hour period, so therefore this lambda will remain the same. And part B, what is the probability that at least 4 arrive during a 1 hour period. Okay, means, so this is part B, and at least 4 arrive means that all the other values will be greater than 4. So here the probability of x would be greater or equal to 4. Okay, so this is what we have here, but now this is greater or equal to 4. In these type of question, what we can do, we can use the Poisson formula as well, but here it would be feasible for you to use the Poisson table, and that would be in the form of this formula. So therefore I have to convert it into the notation which will be less than or equal to the value of x. So therefore in order to transform it into this formula, what I can write here, I can write it like 1 minus probability that x is now less than or equal to 3. Okay, so these are the values which are now less than this 4. So therefore it will be less than or equal to 3. So here this is the thing which we will find out for part B of my question. Okay, so now let us solve it. Okay, for solving it, let me use this color. So here, in order to solve it, I have to use the formula because it is not in the form of this. So therefore this is a single value. So therefore the formula for it is L exponential of minus lambda of x divided by x factorial. Okay, let me put their values. So it would be exponential of minus 6, which is the value of lambda. Okay, similarly lambda raised to the power 4 divided by the 4 factorial. Okay, solving it, you will get what? You will get the answer of part A of my question. Okay, similarly, so now here, in order to find the probability that x is greater or equal to 4, because the values are here at least 4. Okay, so 4 here, 1 minus probability that x is less than or equal to 3, as this formula is now according to this one. So therefore in order to solve it, what do we have to do? Here the value of x is 3 while the value of lambda is 6. So therefore now I can use the Poisson distribution table, because now I have all of them in the form of this table. So let us move to the Poisson distribution table where the value of lambda is 6 and the value of x is 3. So let us move to that. So the value of lambda is 6 here, and the value of x, which is 3, is here, okay, because all of this is now in the form, let me show you, in the form of this formula, okay, where this is what we have transformed it into, okay. So therefore now, in order to find this value, this would be 0.1512. So let me write it, 0.1 minus 0.1512. Okay, so if I will subtract the values from it, we will get the answer from it. Okay, so that is basically the solution of what, this is the solution of part A of my question, and now similarly the solution of part B of my question is this one. Okay, so in part C of our question, what is the statement? If we define a working day as a 12 hours, what is the probability that at least 75 small aircrafts arrive during a working day? Okay, so this is the statement, and here as the average rate per hour is 6, okay, which is what, which is the lambda. So for 12 hours, what it would be, it would be 6 multiplied by 12. Okay, so the average number of hour here would be 72. Okay, so this is what, this is the lambda. So on the basis of it, what is the probability that at least small aircraft arrive during a working day? So we have to find it out, and this is what we have to find. X is greater or equal to 75, which is a very huge number. Lambda is huge, 75 is huge, and in order to find it out, as the limit is now infinite, so what we can do, we can find it out by Px is less than 75. Okay, so we have to use this one. Now this is again a very huge number, and in order to use it and in order to solve it, we cannot use the Poisson distribution, but we have to use what? We have to go to the continuous probability distribution, and that is the normal distribution. Okay, so as we know that in Poisson distribution case, as this is a Poisson problem, but due to the very huge number of the lambda and the probability item or the limit of the probability, we have to move to the normal distribution, but the mean will remain the same, and mean would be 72. And as in the Poisson distribution, the mean and variance remains the same, so variance is also 72. Okay, in order to find the value of the standard deviation, the value of standard deviation is square root of 72, because this is the square root of it, and when we will find it out, it would be what? 8.48. Okay, so these are what we have. Now in order to do it by using the normal distribution, we have to use the z-score. Okay, we will also discuss it in our upcoming videos, but what is a z-score? In order to do it, we have to write the 75, and as the value of x is less than 75, so therefore we can write here 74.5, which is the thresholding factor. Okay, from it I have to remove the value of what, or first I have to remove the value which is the mean value divided by the standard deviation, which is 8.48. okay, this is what, this is z equal to x minus mu divided by the standard deviation. This is the formula I'm going to use. Okay, so this is what we have to do. Now after finding them out, the answer of it, or the value of z, would be 0.2946. okay, so this is the value, which is the value of z, or the value of z is 0.2946. okay, so we have to find it out for it, and for it the probability or the value of 8 we want to find out, and it would be 1 minus the probability at which the value is 0.2946. 0.246. Okay, so we have to find it out. So in order to find this value, what do we have to do? We have a table which is called the z table. Okay, so let us move to the z table and let me find out here the value of 0.2946. so this is z table. Okay, let me see it here, 0.2946. these are all the values here. These are all the values of z, and these are the additive factors. You can see that after the decimal point we have only single item, and these are the additive factors with them. So let us move to 0.29. okay, so this is 0.2, and with it we have 0.29. so if 0.2 is subtracted, the remaining one is 0.09. okay, so the 09 is here, so here it would be 0.6141. okay, so this is the value we need to find out. This is the column, this is the row, so 0.6141. so let me write it, 1 minus 0.6141. okay, so after subtracting the value from 1, we will get the answer, and the answer of it would be 0.3859. okay, so that is basically the solution which we wanted to find out here, and that is basically the solution of our question, in which we have used this z score by using this formula, and that's what we have moved from Poisson to continuous normal distribution. okay, so that's it for today, in which we have completed our question 5.66. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.67, and the statement of this question is: the number of customers arriving per hour at a certain automobile service facility is assumed to be follow a Poisson distribution with mean lambda is equal to 7. okay, so this is for a single hour. So part A of this question is: compute the probability that more than 10 customers will arrive in a 2-hour period, and B, what is the mean number of arrivals during a 2-hour period. okay, so one common thing in part A and part B we can see is this 2-hour period, because this is the average number of customers in an 1-hour period, but we have to find it in part A and part B for 2-hour period. okay, so therefore let me first solve part B of my question, and in this part let me solve it, and let me have the other color for it. In this part, this is part B, and in this part, what is the number of arrival during a 2-hour period. okay, for the 1 hour, this is lambda 1 and this is 7. okay, therefore for the nth hour it will be lambda n will be equal to n multiplied by 7. okay, therefore now for a 2-hour period it would be what? It would be lambda 2 equal to the value of n is now 2, so it will be 2 multiplied by 7, so it would be 14. okay, so therefore it is now the average number for 2 hour is now 14. okay, so now on the basis of this we can solve part A of our question. So in part A, what do I have to find out? I have to find the probability that more than 10 customer will arrive in a 2-hour period. okay, so if x is the number of customer, so x is greater than 10. okay, so this greater than 10 can be any value from 11 to infinity. So therefore we can simplify it by 1 minus probability that x is less than or equal to 10. okay, so this is the value. okay, and also the value of lambda here is 14, the value of x here is this 10. so therefore here for this one I can very easily use the Poisson CDF table, okay, which is given. So in that table what I would do, I will find out the value for x equal to 10 and for lambda equal to 14, and I have to subtract it from 1. so let us go to that table. okay, so in this table let me move to the value of lambda equal to 14. so this is the value of lambda, which is 14. okay, and the value of x is 10. okay, so therefore let me move to the value here. so this is 0.1757. so 0.1757. okay, and in solving it the answer of it would be what? 0.1757. A243, and that is what? That is basically the answer of the part A of my question. The answer of part B is given here, and that's what we had to solve in our today's question. Okay, so that's it for today, in which we have seen the solution of question 5.67. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. Today we are going to discuss question 5.68, 5.69 and 5.70 because of the very close relevance between these questions. So what is the statement of question 5.68? Consider exercise 5.62. What is the mean number of students who failed the test? Okay. So what was the statement of question 5.62? The probability that a student at a local high school faced the screening test for scoliosis curvature of the spine is known to be 0.04. Okay, so this is what? This is the probability of the next 1875 students at the school who are screened for scoliosis. Okay, so the next statement of it is of no relevance for us with respect to question 5.68. So here the probability is given, that is 0.04. The sample size here is 1875, which is the P, and which is n, and in order to find the mean number of students who fail the test, here we have to use the formula which is mu equal to np for the Poisson distribution. Okay, we have n, we have p, we can put the values here, and on the basis of it we will find the value of the mean of the number of students who fail the test. Okay, so mu equal to np is the formula which we will use here. If we don't know the value of p, how can we find it out? We can find out by writing the number of the samples in a set which we want to find the probability of, divided by the total number of the items, okay, which are in the sample space. Okay, so this is what, from it we can find out p, and n is what? N is basically the amount in the sample we have here, which is n. Okay, so this is mu equal to np. In most of the cases you will be given the value of p and n, and if it is not given, you can find out by the procedure which I have mentioned here. In question 5.69, the probability that a person will die when he or she contracts a virus is 0.01 of the next 4,000 people infected. What is the mean number who will die? Here again n is given, here this p is given. By using the same formula we can find out the value. So let me find them out. So 4,000 multiplied by 0.001, okay, it would be what? It would be this. Okay, this will be here and it will be 4. Okay, so this is the mean number of the people who will die is 4. Okay, similarly here in 5.62, what was the answer? It was 0.004 multiplied by 1875, and multiplying them we can find the answer of question 5.68. okay, now question 5.70, a company purchased large lots of certain kind of electronic devices. A method is used that rejects a lot if 2 or more defective units are found in a random sample of 100 units. So A, what is the mean number of defective units found in a sample of 100 units if the lot is 1% defective? Here this 1% is what? This is the probability, and from it I can find it out by 1 by 100. This is 0.01. okay, and the number of items here are n, which are 100. okay, so this is what? N is mu is equal to np. N is 100, this is 0.01, so multiplying 100 with 1 by 100, it will be 1. okay, similarly the variance of it in the case of the Poisson distribution, mean is almost equal to the sigma square, so therefore the value of the variance will remain the same. okay, so this is the today's videos in which we have discussed the mean and variance of the Poisson distribution, and I have told you that how to find out the mean value, the cases in which the sample size or the samples are given, which is n, and probability is given, and the other cases in which the probability is not given, the formula to find it out is also mentioned in this video. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon.